The next speaker will be Tudor Girba from Romania and from Switzerland currently. And he is a software environmentalist and CEO of Think.com, where he works with an amazing team to make the inside of systems explainable. Much of the work is embodied in Glamorous Toolkit, gtoolkit.com, a novel environment that enables moldable development, a way of programming through custom tools built for each development problem. When I asked him the question, what is his one sentence for the future of developers, he said, don't rely on reading code, optimize code reading. So this is his take. Please welcome on stage with a warm applause, Tudor Girba.
Hello, everyone. How many of you have heard of moldable development before? Excellent, because that's what I'm going to explain. Nobody here heard of it, or close to nobody. So just one question before we start. How many of you would like to understand your system better, faster, easier? Everybody. This is awesome, because that's exactly the problem that we are going to try to look at today. So at Think, my name is Tudor Girba. I am the CEO of Think. At Think, our goal is to make systems explainable. Trying to figure the systems out today accounts for the single largest expense we have in software development. And if we can optimize this one significantly, we have a chance of significantly affecting productivity. But more interestingly, we have a chance of affecting our joy. So, when I talk about joy, how many of you would associate excitement with working on an old legacy system? Very few. The vast majority of you are probably working with some sort of an old technology or around an old technology. In fact, a system that is 5 years old is probably going to be old enough to count like that. But you don't particularly associate excitement with that work. We can change that. We should change that. It's literally in our grasp to do that. And so that's what we want to talk about. Moldable development is a new way of programming. Because the thing is, if pretty much everybody ends up in a place where it's not so particularly maybe productive or joyful, maybe there's a different way to look at the problem that ends up with different properties at the end. So what is moldable development? It's a way of programming through custom tools. Now, I guess that some of you probably are using tools. I hope so. And I guess that you're customizing your tools. So this idea of custom tools is probably nothing new. However, we are saying here that we want to customize the tools. We want to create custom tools for every single development problem we have. That means multiple times per day per developer. And so if we do this, we end in a world where we have thousands of custom tools. Not a few tools, and definitely not tools that you can actually name. And when I say thousands of custom tools, I don't mean globally. I mean per system. So what does that mean? Now, in order to explain you what that is, it's a reasonable departure from what the typical, the current state of affairs is. I'm going to use a wordly map here to guide the conversation. How many of you know what a wordly map is? Okay, not that many. So a wordly map is a notation to try to reason about how things evolve over time. So typically, things start in a genesis where you're just having an idea, and then you're maybe building some sort of a custom solution for that, and then it becomes a product, and then it becomes a commodity. An interesting thing is that most things evolve from left to right. And as soon as something goes from left to right, it opens up an opportunity on the top left. And as soon as something becomes a commodity, a new thing is possible on top that was not possible before. So this is why this kind of notation is kind of interesting. Now, so what do we talk about? Well, we want to say we have business people, developers, whoever has a stake in a system. They want to reason about the system. That's the goal. The goal is to be able to investigate the system proficiently, but also calmly. Now, this investigation requires an exploration. So you have some sort of a problem, but you need to, in order to reason about that, you need to explore it. And then this one enables conversation. So the explorations enable conversations. Conversations require explorations. But then all of these are based on how do we perceive the system. And there's, of course, this perception of the system requires some way of analyzing that system. Eventually, this one gets to the development experience. Now, this sounds a little bit, maybe a little bit too abstract. So let's see how we see the current state of practice. So many of our investigations are actually driven by a little bit of gut feeling. We believe things are in that way. We say, oh, I have a hunch, I'm going to do that, which is OK as a way to start. And the way many of these investigations are carried out, they involve a lot of manual inspection. And this manual inspection often goes and looks into the raw data. So we have a kind of a raw data-centric view of the world. And this, because of that, it leaves room to quite a number of beliefs that are perhaps less necessary. Now, these beliefs are documented or made available through some sort of manual views. That are the way you produce those views is using the typical tools you have. And we call this one monolithic tools, because when you look at a development environment, right, that's very often how we make the investigations. And they're very much like, it doesn't matter which problem you look at, they kind of look the same, right? So let me give you an idea of how an investigation could potentially be different. So here I have a case with a system that started from, they had a legacy system here. And in this legacy system, they had a legacy database. And in fact, this was not just one system, but it was an ecosystem of systems that was relying on this central database, which had the core data about the customers that this retailer was relying on. And so their problem was that they wanted to migrate this database to a new service-based solution. And so they deemed this one, especially at the beginning of the pandemic, they deemed this one to be the most important strategic project in their organization because they needed to go from an analog distribution to a digital distribution. And this involved not only making the access to the database a little bit more available, it also implies having finer grained access to the data. But then, about 6 months into this very large initiative, an important initiative, they figured out, oh, actually, this is not just a database migration problem. It's also a system problem, because we have these systems, these apps, that are actually relying on the database. So if you're going to migrate this database and put it somewhere else, we're going to have to change the systems. And then we said, oh, great, excellent. But then they said, we have one problem. We don't know where the systems are. I said, what do you mean? Oh, the systems are developed by third parties, sometimes hosted by third parties, sometimes hosted by us. And we don't know exactly where the sources are. OK. So then they said, could you, they wanted to say, we tried to figure out, and what we're assuming is we need to find the apps and give them the task to migrate their data. Because they said, that's what, it should make sense like this. And then they said, well, our way of working should be like this. We're going to take the apps and create little tiny services in which we encapsulate microservices, in which we encapsulate the use of the central database. And once we take all these red things and migrate them to the blue ones, then we can decommission the database and switch it to something else. And it sounds reasonable, right? It's not a bad thing. Except, again, that they didn't know which apps should be subject to this transition. So what do you do in this situation? Now we need to investigate. It's a really important problem. Again, the problem here is not cost. The problem here is opportunity cost. Because if you don't move fast, the window of opportunity goes away. That's the problem. And so the cost that we typically think of in terms, when we're developing, are completely different when you think about the impact of not being able to answer a fundamental question about your system has on the business. So then we said, well, what kind of data do we have? Because we don't have the sources from the apps. And so we found out, so in this legacy database, we had 2 schemas, and we managed to convince them to give us access logs. So we basically instrumented the database for 1 day, which was a typical cycle that they had, and this gave us a good enough idea of what kind of things, what kind of traffic the database would have. Now this was old database. This is not the new one kind of. In fact, even the export here was in some funky export format that was not directly parsable, so we had to patch things up. On the other side, on the app side, we had some partial sources, but even more interesting is in the log files, what do you get? Do you get the names of the apps? No, you get IPs, because that's what database knows. But so somebody has to give me the mapping between the IP and the app. They didn't know this either, so we had to somehow be able to go and figure out what this mapping was. And then we did have access to a few of the applications that they did know about, and they did started to look into these web services. So we got the access log at the web services level and the Java sources. So once we had this, we could build a picture like that. So what do we see here? Well, the black circles here are systems, and the red squares are tables in the central database. The blue things there, those are the web services. So we can see that some of the web services, some of the apps are using the web services, which are actually using other web services or relying directly on the database. So the assumption that they had was that things look like this. You have one application that are using a cluster of independent tables. But then when we looked closer, we saw there are actually clusters of applications that have things in common. What does this mean? Well, it means that you can't just delegate the task and split it and give it to every individual system. You have to work, these 2 systems, they probably have to work together because of this common thing. So this idea, this view, completely changed the conversation. All of a sudden, there was no room for believing that something is in some way. We could have a completely different kind of conversation. So, of course, now, this view is interesting, but you don't want to just have the view. What we want is we want to be able to navigate in this space. Highly, highly interactable. Now, the question is, how do you build a tool like this? Because there is no tool that will take an unparsable log file, find some Excel file with the IP mappings, and have some access logs from web services that is in a different format, and put it all together, together with the schemas. There's no tool out there that would do this. So that means that you have to build a tool for the problem. There is no other way around. You have the problem, and then you build the tool, which is a slight inversion from this other thing, which is a typical thing when I have a tool, and I fit all my problem to that tool. And now, what happens here is, so how many of you find this particular picture beautiful? That's interesting. A little bit like double the amount of people that found it exciting to work with legacy systems. The reason this is beautiful to me is not because the system is beautiful. It's because it's comfortable for me to reason about it. The only thing I changed, I didn't change the system. The only thing I changed was how I looked at the system. And there is tremendous power in being able to control the way I'm going to look through to a system. So this is what we mean by investigation. And so the world that we talk about is a different one. And we want the investigation to be mostly hypothesis-driven. We have a hypothesis, we want to see it, we want to investigate it in some form, and see it against data. Now, we take this manual inspection, so instead of actually going and arbitrarily looking through systems that we, first of all, don't know where they are, and second of all, they're way too large to actually know where to look, so nobody will be able to do it by hand. Instead of that, we're going to take some time and do things, this practice moldable development, which is we're going to create a tool or tools that will summarize the system for us. And here we don't talk about generative AI. We don't talk about magic. A simple practice of building engineering tools. Now, this one then enables a model-centric view of the world as opposed to raw data, because we can build mental models, and we can outsource this mental model into the tool itself. And we can carry the conversations evidence-based. And interesting enough, we take these manual views, and instead of drawing them by hand, we're going to generate them. And the reason is this. If you have a system, if you have a picture about your current system, and you drew the thing by hand, you just documented your belief about the system. You didn't document the system. Because the system looks the way the system looks, regardless of whether you know it or not. So the only way to know what the system is actually go and ask the system. Because if you drew the thing yesterday, you don't know how it looks today. So now here, I gave you an example of a large problem. But there are actually sometimes smaller, tinier problems. So here, for example, I'm now showing you, obviously, I'm inside the tool here. And I'm showing you a book here, which is kind of like a knowledge management. But this book actually documents the environment that I'm showing you here. And here, this is an actual problem that we had when we developed the environment. So our environment has an editor. And this editor is built in a higher-level language, but which wraps some logic which is in Rust. And we had this issue that when the cursor was at the end of the paragraph, we couldn't move it up and down. It got stuck there. And we had the issue open for about 8 months. And it's not like we didn't know that the problem was there. And it's not like it was not annoying. It was annoying. We knew about it. We tried to solve it, and we couldn't. Until, of course, one day, every time this happens, we know exactly one thing. Every time it's not comfortable to understand what the solution should be, it's a very interesting sign that you don't understand what the problem is. So every time this happens, we spend the time to go and describe the problem. So here's what we did. We took a trace. So this is a snippet here in my book, which is, of course, executable, because in this century, books should be like that. So I have here an object. And this object I have an inspector over this object. Now, because this is an editor, it shows me the text. In fact, here, I can go and type more things. So now I said, OK, so this is in the higher level language still. But what I want to take another snippet here. So I have a little notebook with the context of my inspector. And when I execute this one, I get the low level object. Still in the higher level language, but here I can't. It's just doing rendering. I can't edit here. But this one is just a thin wrapper over a Rust object. So now I'm inspecting the Rust object. So I just left one runtime, and I went into this other world, another language, right? And I just crossed the barrier like that. And I said, well, in this paragraph over here, I see that there are line ranges. So when we looked at the line ranges, we saw this. The first one was from 0 to 38. The second one was from 38 to 70. The moment we saw this view, we knew what the problem was. So remember, the problem was at the end of the line. So when we saw the documentation, and we looked at the raw inspectors before, and we saw this one at a time, we saw just 0 to 38. Then we saw, OK, so it starts from 0 all the way to 38, including 38. But of course, once you see that 38 is on the first line at the end, and 38 is on the second line at the beginning, it must be that 38 cannot be at the end of the first line. Because, right? So one of the end of the intervals must be open. That's it. But only if you see these things next to each other. There is no fanciness in this view. This view is as beautiful as the picture that I showed you before. Why? Not because it's shiny and it's colorful and so on. It's because it makes the problem so obvious that the solution becomes obvious too. That's the beauty of creating these tools. So we literally we took the time to build the whole infrastructure just so that we are able to comfortably go from this world to this world. And only after we've done this, so when we look at this one, for example, this view is actually implemented in Rust. But we can seamlessly just have an environment that just gives us views provided by different places over the system that we put together. Once we've done this, the problem became trivial. So it completely changes that conversation. Now, it's interesting because when we talk about conversations, here's a different one. It's not just about how do you investigate problems. It's actually also how do you think about design. So things like domain-driven design. So here I have, for example, another part of the book is a case study, which is just for tutorial purposes. It's a small game. So we can see here it's a Ludo game, and this means that I have these tokens, and they have to go across the board and make sure that the other ones are not capturing you again. So here I have a few tokens. A has to play, and I can go and move A, for example, there, right? So I can play with this like that. So that's interesting, right? This is an interface that if you think about from a user perspective, that's what you would do, right? You would say, oh, I have an interface that I can play, I can poke at it, and I work with it. That's great. But I want to take a look slightly behind that curtain. Because one thing that we know from ever since personal computing was invented was that there is a way to transform and describe computation in a way that humans make it comfortable and can actually play with it. This idea of this interface didn't exist like 40 years ago, 50 years ago. So, but then at some point, somebody figured out that it's possible to create a UI that makes humans be able to comfortably work with computation. Except that we only did it at one place. But the question is, what happens with the rest of the layers? What if we can do the same there? So where does this picture come from? Well, this picture comes from something that looks like this. We call it an example, which is, if you look at it up to here, I'm setting up a game, I'm doing something with the game, and then I'm asserting something here. So it looks like a test, except that at the end of it, I'm returning an object. Like most tests, they create this object, they ensure that it has beautiful properties, and they say, the best thing we can do with this is throw it away. We thought, well, maybe that's such a big waste, so let's not throw it away. Let's change this little thing. But then when we changed, what happens here? There's another thing about tests. Tests are interesting as long as they are red. As soon as they're green, nobody cares about them. Nobody looks at them. That's like a terrible thing, I think. Because just take a look at this one. This one is green. It works. So it's a green test. But when I run it, because it gets me an object, I actually get to look at the object. It returns an object, but the inspector over that object can give me views to work with it. So this is the view that I can see from the outside, right? It's just I can go and play with it. So I can go and roll the die here and then move A, for example. But I can equally just want to take a look behind the scenes. So for example, here, the recording game object tells me there's a view called players. So I can take a look at that one. So the players now, I'm looking at player A, has 2 tokens. And I can also see them as a list. And if I click on this token, I can see where the token is. I can see where the other token is. So all of a sudden, I can figure out, wow, there's a recording game that has players which has tokens. So there's one thing I can do. But the other one is like, oh, this looks interesting over here. There's something called moves. Well, that looks like the history of the game, because I don't know how this thing got into this place. So I can actually play now my object, and I can see that D was actually one point there, and then A captured it and pushed it back. Now, that's kind of interesting. How many of you like this? Because we're just taking we're taking a system, we're taking an object out of it, and say, oh, how is this one working? And now you can reason about it, but you have not read any line of code. Because these views, they compressed it. But then we can take it a step further. Because we can say, well, let's go back to our original thing, right? We said, this is a documentation. So this is something that we can communicate. We can teach about our system. So to whom can we communicate this? Well, up to now, I just communicated with you, and we're talking about technical things. But sometimes you communicate with your end users. Should your end users care about the inside of your system? Should they? Who votes for yes? Who votes for no? Excellent. Now, let's put this at the test a little bit. The first thing you do when you open a game, what is it? You want to know the rules, right? So among those rules, right, the moves are kind of important, aren't they? So we want to see some documentations like this. You want to see this is how an initial move looks like. This is a capture move. Now, how many of you draw these by hand? Why? This here, that actually we can use as a means to communicate with our customers, literally comes from that object inside the system, viewed in a way some human deems it interesting. That's it. The interesting thing, though, is that this view is also interesting for debugging purposes. The way we think about how we communicate and how we can reason about systems is way too ancient, way too separated by walls that actually don't have to exist. Systems are much simpler to deal with than we do today. We just complicate the problem needlessly. So this is how conversations can change as well. And then, of course, we talk about the system awareness and the difference between evidence-based and belief-based. So when I started a long time ago, about 15 years ago, on this journey that ended up with Moldable Development, I once met a team, and there was it was a startup, or not a startup, it was a small company. I had about a team of 10 people, and they, at the core of the system. And they got in a room, and they were just starting to practice more agile based development, and they were very excited by this idea of various meetings and exchanging ideas around tables. And then what they said is, well, we should, and I said, okay, let's put together this. Enumerate all the services that you know about your system. And we just took all the notes, because they're very popular, even today. So we did Post-it notes, and we did a union of everything they knew. They could enumerate 12 of them. Then we looked into the system, and we wrote a query. There were 20. So here's the problem. If you want to bring people in a room and have them make decisions, but they don't have the initial data in the first place, there is no decision is going to be right. And it's not because people don't care. It's because they simply don't have the information. Relying on memory when it comes to systems is just wrong, because systems, they evolve all the time. What we want instead, we want on-demand ability to reason, to get the information that we need in a form that we can consume as quickly as we can. That's what we should strive for. So then, of course, we end up with different kinds of analysis. So here, for example, very, very briefly, here's how the routes, in Ruby looks like. This is Ruby system, so you can see these are the routes over here. And so you take a text editor, and then you can see of those. Now, the only tiny problem is that each of these are actually findable somewhere in the controller. There's a controller logic somewhere else in another file. But you don't see it over here. On the other hand, if I take a different perspective, a model-based perspective, and I say, well, here are my routes, and I'm going to take one of these routes, and I'm going to look inside the route. And that's what's a route? Well, it's an object. And it's going to show me, well, here's the source. But it can also show me, here's the controller source. Now, all of a sudden, I don't have to think. It's right there. And this is beautiful, too, because the problem that was difficult before to reason about just became much easier. I took friction out. But then we can take it a step further, and we can do something like this, where we say, well, look here, we have get, and we have with update. And we can make it delicious, not just informative, absolutely delicious. And it's not about what technology the system is. Literally depends only on how you look at systems. So normally, when we think about tools, we think of them as being rigid thing given to us by some god somewhere. They say, this is how you should look at systems. So for example, if I give you objects, just objects, right? All inspectors in the world are going to show me values, variables, and values. That's it. And they all look the same. Now here you have 20 objects, and they all are different, but they look the same. If, on the other hand, I take those objects and I just show them differently, you take this problem that just feels like this and literally becomes delicious. It's beautiful to look at these things. And then it's not just the individual views, and this is where the interesting bit comes into play. Because what we're saying is that the development experience has to be made out of composable micro tools. And the composable is the key here. We saw that we can have micro tools. Here we're talking about just one little tiny object, and I can change the way I look at it. But really the power lies in how I compose these things. So for example, I have here one object, and I look at it in some way, right? This is my game. And I want to have here a little query, which gives me another object. So now I have this view over here, and I have this other view over here with my move object, right? The one I saw before. But they don't know about each other. The whole scene, actually, is built dynamically. So this is a view on that scene. I have a frame, a place where I put things. But then there is a way in which I compose things, logical things. I have one pane over here, one pane over there. Then I have there the composable snippets and views. So I can have views there, and I can have my snippets there, and then the contents of the view over there. They don't know of each other. There's a way in which we can compose this, which means that if I build one view, one extra view, I don't just linearly increase the amount of narratives I can tell about my systems. Because I can combine these views with all sorts of other places I can get to the object from. And so like this, I can generate many more narratives about the systems on demand at very, very low cost. So now, of course, this is a departure, as I said, from a typical way in which we perceive tools. And we think that the key idea here is that tools have to become tiny and composable dynamically and on demand. So we built an environment which is called gtoolkit.com. It's a free and open source environment. The goal here is to educate about what is possible. This environment is not just a tool with which you can learn moldable development and practice it in actual problems. This is what we do at Think. We basically solve hard problems in companies, and we are exclusively using this technology. But even more interesting about the technology is that it's an extensive case study itself. This is a visualization of the whole code base of Glamorous Toolkit. And here we have highlighted with blue are all the places in code that have at least one extension, so one little custom tool. And in green, we have those that have examples. And we can see there's just these ideas, these two ideas. They cover the whole thing. In fact, when you open Glamorous Toolkit itself, it comes with thousands of tools, thousands of little extensions, all allowing us to tell narratives about our systems with arbitrary levels of abstractions in arbitrary order. And when we're going to work on a new system, we are going to build thousands of tools more. And this is not just an extra cost. It actually decreases the cost dramatically. So the interesting bit about Glamorous Toolkit is that it is a case study that documents how a system built following moldable development can actually look like inside. Thank you very much.
You were really fast. Thanks a lot. We have some place for questions, so this is a Slido link. Please use Slido. You can also rate Tudor's presentation using the poll. It's active. But please now go for the questions. I'm looking for the assistants. Are there any questions already? Not yet. So the first question, is it usable for any platforms like C# or whatever, or what is your take on that topic?
Well, yeah. So Yes, we use it for arbitrary technologies and arbitrary languages. And the way you do it is every time you don't have a tool, you're going to build the tool. That's it. So if I find a new language that I don't know about, I'm just going to take the time and build a parser for it and then build the tool support for it. And you might think, wow, that sounds like crazy. I'm saying it's crazy not to do it. Because the alternative is just to look into these awfully looking textual things, and that's terrible. So that's basically how we do it.
Okay, we have a kind of funny question. Does GToolkit have a dark mode?
A dark mode? Excellent question. It's possible to make it dark if you know what you're doing.
Okay, what language parser is used for this?
For which?
For this, I think for GToolkit, I guess. Who you have? Are
so
you here?
Like in this one, for example, we saw Ruby, being able to look at Ruby files, for in this case, statically. But in the case study, for example, with the logs, there we had built other kinds of parsers. For the runtime itself of Glamorous Toolkit, we use a combination of Smalltalk, Pharo Smalltalk, and Rust at the moment. And what Glamorous Toolkit provides is a whole new environment built on top of that.
Cool. We have a question from Simon. How are these tools versioned? Can I keep them in my repo alongside the systems being documented?
That is a super cool question. So the question is, how are the tools versioned? So first of all, Glamorous Toolkit is built out of sources stored on GitHub. In every one of these systems, right, all the extensions that are built that are system specific are going to be versioned together with the code of that system. So you're going to have your Git repository, and you're going to put the extensions there, and you're basically going to build a new image of like a new distribution of Glamorous Toolkit that is going to be system specific, kind of like how you do it with Docker, for example.
That's great. What's your opinion on using tools from data science for analyzing problems in software systems?
That's a very good question, because that's exactly what we're doing here. We're applying data science for every single development problem. Now, Glamorous Toolkit shows how you can you can treat knowledge management, data science, API browsing, programming exactly the same way. But there are other ways. There are other tools out there. There are other opportunities out there that exist. So if you take a Jupyter notebook and you have a parser for it, then all of a sudden you're in a much better position than just using the default editor. I'm just saying that if you want to see how far this can go, take a look at Glamorous Toolkit.
Okay, is this a custom implementation for each software, or is it a drop-in code for the Ludo codebase?
I don't understand the question.
So is this a custom implementation for each software, or is it a drop-in code for the Ludo codebase? Still no? Are you in the room?
Go ahead. So the question is, if I understand correctly, is if I look at this one, where did this view come from, right? So if I look at this object and I look at the move, and I look at, oh, you don't see our screen. Anyway, so you were looking at a custom visualization, right? Where does that one come from?
Please.
So like this one over here, right? Somebody built it. You can think of this one, a very basic way to think of it is like a print on, right? Everyone, how many of you are writing a print string or something like S string, to string, whatever the flavor of your language is, right? To just see it in the console, right? That's just text, so why limit it to text first, right? Why not print widget? It was much more interesting. And second of all is that there is no single perspective of anything in software. The crazy thing is that even one single object that you would think, well, who cares about one object? But even one object can entertain different perspectives, as we've seen here, right? I can see a board, or I can see the players, or I can see the moves. 3 different perspectives for 3 different points of view. And so this means that the core idea of the environment is to host this perspective. So you don't have just 1 2 widget, you have many widgets. So that's it, and that's a new practice. And this is an emergent practice. So the way we see it is that once tools are composable out of tiny things, then you'll be able to generate these views. But they will enable a whole new way of thinking about programming. So the skill of actually building the tools is going to be as pervasive and as needed as the skill of ops in DevOps. It's a service.
Okay, one last question. Has the code to be in a concrete form, or does every structure work?
That's a very interesting question. Do you want, so there are always things that appear in the space of how do you make things explainable, but they say, I have this interface, but the code must use this language, or it must be this format, and it must have this constraint. This works until it doesn't, and in most cases, it really doesn't work, right? That's actually, by the way, the promise of low code, no code, whatever. They just say, oh, you can do very quickly things, except that as soon as you want to do slightly something different, then you're hitting a wall and you can't do it anymore. So the problem, the opportunity here is to say, well, we want to create an environment that adapts to arbitrary code bases. That's why I showed you this use case over here, because this one has unforeseeable structure of data. Nobody can predict this data structure. You have to create it and adapt the tool after you know the data structure, not before.
Okay, thank you very much. And we have